Hello, my name is Sapta Sengupta. I go by Sapta Sengupta, and I'm a global director of product marketing here at Denodo. Thanks for having me today for this presentation, and really a pleasure to kind of be with you guys for the Big Data and AI Toronto conference. Hopefully, you guys are having fun listening to other sessions, and my hope is that at the end of this presentation, we will have some good takeaways with you. So with that, let's get started. Today's presentation for me is around logical data fabric, how that helps in building a unified data warehouse and a data lake. I'll come to the introduction of what we mean by logical data fabric. Some of you may have heard about it, some of you may have not. And of course, you guys are very aware of data warehouse and data lake. With that, also, we know that a lot of people are talking about this term lake house, what that means, and how a logical data fabric can unify a data lake and a data warehouse. So this is the agenda for today. We are going to kind of talk about, when I say introduction, it's like how the data storage, analytics, data and analytics, that entire market is moving, starting like a few decades back and where it is today. We'll talk about how things are working for data lakes and data warehouses, how things are changing in the market. We recently saw a few observations from a report from TDWI around data lake and data warehouse and logical data fabric. So we'll talk a little bit about those things. We will talk about what is a data fabric and what is the logical data fabric. How does that apply to a data warehouse and data lake? We'll take a customer example, one of our customers, Autodesk, how they have created a logical data fabric for unifying their data lakes and data warehouses. And probably we'll take some questions and what are the next steps for you in your data virtualization or logical data fabric journey. So if we look at the history, we see the evolution of data repositories starting back in 1980s all the way from today. So there were databases, ERP systems back in 1980s. We know that because there were lots of data silos, things were getting consolidated in terms of operational data stores and data warehouses, which were quite predominant in 1990s. But those were not so useful as soon as social media data, cloud data, all these things started taking play in our day-to-day data life, because as we know, to physically store data in data warehouses and operational data stores takes time. And a lot of time, the social media data, geospatial data that comes from the field is not so useful if you spend a lot of time sit on it. And so it is actually useful real time. And that's where the concept of data virtualization becomes a very important thing. Of course, in 2010s, data lake became a big deal because we are generating, all companies are generating terabytes and exabytes and petabytes of data. And everything is data driven, as they say. Like these days, not a single company is anything else but rather than a data company. So every company is a data company first, because digital transformation is happening. This is truth. Everybody is taking data-driven decisions, and then they are a retail company or a pharmaceutical company or a healthcare company or banking or whatever it is. So, and that's where data virtualization makes a lot of difference, and we'll get to it. And as data lakes are coming into prominence, we know that there are certain use cases that are very important for data lakes. For example, data scientists, we know, or BI analysts, they like wrangling with data. They want to play with data, and that's where data lakes, which are like sometimes these data are kind of, it's more like a dumping ground for data. And that's what 2010 brought to us. And then mobile, web, visualization, all these things became very critical. And right now in 2020s, the Internet of Things, the connected devices, autonomous cars, we know we are living through it. So that's where we are, and then we'll talk about how things are playing in the market. Now, we know this is a fact that every company is moving some of their data or all of their data to the cloud. Now, does that kind of solve the data warehouse data lake problem? Can we place all data in a single cloud system or a single type of a storage inside the cloud? Is that realistic? Probably not. And not probably not. I would like to think the answer is no. So whether you guys are in a hybrid cloud infrastructure, all your enterprise data, or it is a multi-cloud system, or maybe you have moved to one single cloud, we have companies like Autodesk, our customer, they have moved pretty much all of their enterprise data to AWS cloud. But does that solve the problem? It doesn't, and we'll take a look at why. So here is where I'm referring that TDWI report that we spoke about earlier. Even before we talk about the cloud, because data warehouse, then data lakes can be created on premises or in the cloud, right? So the question we asked ourselves is, can we move all of our data to a single repository in the cloud? No. Now, irrespective of cloud, can a company live with just a data lake or multiple data lakes, or just a warehouse or multiple data warehouses? The answer is, I think, is no, because that's what the TDWI report actually reached out to 150 respondents who are just like you in IT or business or anything to do with data and analytics, that type of a role. And the question was, in your analytics data ecosystem, which of the following are in production today? And we can see there are lots and lots going on inside their enterprise data ecosystem. There is tools for analytics on premises, data warehouses on premises, tools for data integration on premises, the tools for analytics in the cloud, data warehouses in the cloud, data lake in the cloud. So it is a mix of things. That's exactly what we were talking about earlier, and that is the reality. That's what came out in the particular report. And it says data warehouses typically contain structured data, and more often than not are on premises. Things are probably changing. We know that a lot of data warehouses are moving to the cloud. There are cloud data warehouses which are becoming very prominent these days. Data lakes often contains unstructured data and typically cloud-based. To a large extent true, but again, I have seen a lot of our customers creating data lakes on premises. So now, again, for the same questions, for the same report, do I really need a data lake and a data warehouse? The question was, what terms do you and your team use for complex data environments, such as unified data warehouse and a data lake? And people just spoke about enterprise data architecture, hybrid data architecture, modern data warehouse architecture, multi-platform data architecture, distributed data architecture, lake houses, data fabrics, bimodal IT. So there are so many different terms. But very, very recently, we are hearing about this lake house concept where companies are saying, hey, I have your data warehouse and data lake sitting side by side. So data lake becomes more of an extension of data warehouse. And that kind of takes care of all of your enterprise data needs. That is, again, not true. I mean, the distribution we see here, and we talk to our customers on a day-to-day basis, thousands and thousands of our customers, they do not see just a data lake or a data warehouse or even a lake house solving all their problems. And why? What is the point of the unified data warehouse and data lake architecture? The reason people thought that they needed to unify their data warehouse and data lake architecture is because they can get more value for their business from data, whether it's operational or analytical, unify existing silo data environment without consolidating or restructuring them, expand analytics to more advanced forms such as machine learning and AI, capture and leverage emerging and highly variant data types, save costs. So there were very many reasons why companies are looking for consolidating their data warehouse and data lake. And how the consolidation takes place. Do you gonna have that data lake house type of an architecture where there are two separate engines running side by side? So one is more of a structured data, one is more of an unstructured data types, one is more for business users or very specific targeted use cases, which is data warehouse, and data lake is more like more for data science, advanced analytics, futuristic stuff. So some of those are reality, some of those are happening, but that's not going to solve the problem because you still have many, many other data silos many SaaS applications, your data is everywhere, and you know that. I mean, I do not need to tell you. This is the reality, and that's exactly where we are going. And that is why we are going to talk about the concept of data fabric, why that is needed in our modern organizations, modern enterprises, and how that is going to solve this problem. Companies will need data warehouse, companies will need a data lake, but they will need beyond that. And what is that? So before we move to the definition of data fabric and all, I just wanted to kind of look at this where I believe all of you will agree with it, that data lakes were born to efficiently address the challenges of cost reduction. Data lakes were cheap way of storing data, because there were lots and lots of data which are for kind of experimental purposes, advanced analytics and all. Companies did not see value right away, but companies did not want to lose the data, so they wanted a dumping ground for data, and that became the playground for data scientists and advanced analytics team. So that is why they wanted cheaper storage systems where data can be kept for future use cases. And as we are progressing, we are figuring out what all different purposes data lakes can be used. This is a quote from Gartner. Sometime some companies we have heard will say, hey, I think we can probably live with a data lake. The problem is that, of course, we know data lakes lack semantic consistency and governed metadata. And when things are not governed, when things are not semantically consistent, it is just more like a dumping ground for data. To make those data useful, operational, it takes much more effort, and that cannot replace data warehouse. So you still need a data warehouse for certain use cases. You still need a data lake for certain use cases, and you still need data warehouse, data lake plus beyond that, and that is where the data fabrics comes into play, and we'll talk about it. So how are organizations going about it? Like where they need consolidation of data warehouse and data lake, and maybe beyond that. Some companies say, a majority of the companies say actually not applicable or don't know. Some of them will say we are moving our data lake and data warehouse to the cloud as part of our platform, part of a platform with a common semantic layer. It's a physical consolidation. We are moving some of the data warehouse into the data lake or vice versa. It is a logical consolidation. And that is what we are going to talk about today, which is kind of creating a logical data fabric, a logical data layer. So all these different things are happening within the organizations. And final observation from the report is that assuming the coexistence of data warehouse and data lake in an analytical system, which of the following data disciplines can help unify the two by enabling integration, interoperability, data standards, and cross-platform processes? And so people spoke about data governance, master data management, central management of cross-platform pipelines, metadata for technical and business purposes. So the two key takeaways from that is architects own the overall design. They play a very critical role in how data is being consolidated, how data warehouse and data lakes are being consolidated, and how the future lies for in terms of an enterprise data platform. Because data lakes, as we said, like it actually became, I mean, whatever the initial purpose was in people's mind, data scientists, data lake became the favorite thing for data scientists. And so in 56% cases, they say like data scientists play a very important contributing role for various components in the unified environment. Now, we spoke about data warehouse, the data lake, and consolidation of that, and how to consolidate it, et cetera, et cetera. And that brings us to this particular topic where we are going to talk about logical data fabric. So before we go to logical data fabric, I wanted to make sure our audience really clearly understands what is a data fabric. Data fabric, actually, according to Gartner, is an architectural pattern that informs and automates the design, integration, and deployment of data objects, regardless of deployment platforms and architectural approaches. It basically is a composable architecture where there are different layers Like there is a data integration layer, a data preparation layer, a semantic layer, a data cataloging layer, metadata management. There is active metadata management happening inside the data fabric. So all these things together create a data fabric. So here is a little more detailed view of that. So data fabric, you can think of as this like data fabric net that encompasses all your data repositories across your organization, whether on-premises or cloud. Some of this can be RDBMSs, some of this can be traditional analytical BI apps or data warehouses. There are data lakes, cloud data stores that can be again data warehouse or data lakes, and apps and document repositories and all. So I'm sure all of you see all these things like data marts and third-party data, flat files, etc., etc. All of this playing in your data ecosystem. And then there are customers and products and claims and many other things that need the data from various different repositories. And if, because there are so many different pieces of the puzzle playing together, I mean playing here, if you do not consolidate that with a data fabric or a data fabric net, there is difficulty in gathering the data when you need and how you need it. So a data fabric here we are talking about, it utilizes continuous analytics and AI/ML over metadata assets. There is active metadata playing in the background. This results in informed and in some cases completely automated data access and sharing, and strongly supported by some of the top analyst firms. That's how they're defining. I mean, Gartner definition is not much different from the Forrester definition, and that is not much different from the TDWI definition. And so with that, what we are trying to say is this is reality. This is exactly where things are going. So a data fabric is really needed for organizations. The difference between a logical data fabric and a data fabric is there is this data integration layer. In both cases, there is a data integration layer that consolidates the data. And in terms of when we talk about a logical data fabric, basically data virtualization technology, a logical data integration approach takes that part. And that is what the main difference between logical and a physical data fabric is. So irrespective of whether a data fabric is logical or physical, a data fabric is absolutely needed for consolidation of data warehouse and data marts and data lakes and everything else that are the data repositories of your organization, whether on premises or cloud. And that is what we are trying to capture here. In this particular case, it is a logical data fabric. Now, a logical data fabric actually has like 6 different components. I have like a few slides. I'll skip it because we have only certain amount of time for this particular session. But I just wanted to make sure you understand what are the 6 very key components to build a logical data fabric. Sometimes it can be a composable architecture. You can use 5 or 6 different tools to create a logical data fabric. But fortunately, in our platform, Denodo platform, all those 6 different things are baked into it. So one is data abstraction, which is decoupling application and data usage from data sources. Extremely important for business users and IT to be independent and still run at 150 miles per hour. Data integration without replication, that is very important. We know that a lot of times companies constantly are creating data marts, replicating data. When they're operating across different locations and geographies, they're again replicating data. And with the compliance requirements of like the GDPRs and GRC or CCP or you name it, PII information non-replication is becoming extremely important, and that's where logical data fabric makes a huge difference. Easy access to any type of data, we spoke about it. Data catalog, that creates that semantic model that helps in self-service data discovery. And you can basically create a data marketplace where people can come, consumers can come and consume the data, self-service process. That's extremely important. There's unified metadata security and governance playing just in the data virtualization or data logical data fabric layer. And so you do not have to do point-to-point security governance management, and it can be all consolidated in one logical layer. And finally, data delivery. Even though we talk about data virtualization, our platform supports all type of data delivery including ETL or ESB, like API type of use case. There are very many patterns of data delivery that we pretty much kind of support all of it. So you can create your data pipeline with our platform. And while data virtualization remains the most predominant form of data integration method, and so that is what we're trying to talk about. Like in your data integration process, you will see that like there are very many ways of integrating data for different purposes, and Denodo platform, our platform, supports all of it. I spoke about all these 6 pillars. I'm not gonna go one by one. Basically, it's talks about pretty much the exact same thing. Now, how does this apply to a data warehouse and a data lake? This is a architectural diagram which is pretty self-explanatory. As you can see, there is a play of data lake here. There is a play of data warehouse here. And everything goes through the Denodo platform, which is right here. So between the consuming applications and all the data sources, whether they're structured, unstructured, semi-structured, cloud, on-premises, doesn't matter. This is the reality of life. I'm pretty sure as our audience, you can kind of connect this to your own enterprise architecture, and this is a reality. Maybe not all of it, but partially. So you definitely have seen one thing or the other in playing inside your enterprise. And this is just another quick example where our platform can play in a multi-location architecture where, as you can see, on one side, there is the AWS data sources. So there is, and there is a Azure ecosystem. So there are data warehouses and other type of data stores and data lakes being created, whether it's in an AWS ecosystem or Azure ecosystem or on-premises, doesn't matter. You can actually have one data virtualization or logical data fabric piece. So basically what we are trying to say is that there can be 2 Denodo instances residing in 2 different cloud ecosystem, because that way it is talking to the local sources and it solves the latency problem. And these 2 Denodo pieces together actually creates your end-to-end logical data warehouse architecture. And then that can be consumed through any type of consuming applications that you see on the right-hand side. So this is just a generic architecture showing how a logical data lake solves the problem of consolidating data warehouse and data lake. This is a customer use case. Very quickly, a lot of you probably know about Autodesk. They're one of the most well-known kind of 3D CAD design company. And they have been in the business for a very, very long time. And they were actually moving their licensing model from perpetual to subscription based, which is, I mean, of course, we know that that's the way to go in the future. Every company is changing that model, but that actually affected how they were creating their data repositories and where the data was coming from, where they were storing the data. They actually wanted to move from on-premises to cloud. As I said, these guys actually have moved pretty much all of their applications and data sources to the cloud. And they created a data lake. They created multiple data warehouses, I think, at a point, and then they were consolidating, and they had data marts. And then, as you can see on this page, like they have like all sorts of data sources. There are structured, unstructured, all type of data sources coming from various different places on a day-to-day basis. And they wanted to figure out how to put together an architecture which will create that logical data fabric and solve the integration of data lake and data legacy data warehouses and data marts. And this is where things are. So if you really look at it, this is one of their data flow where the structured data comes to data warehouses and data marts and being consumed by SAP business objects through the data virtualization layer. If you think about their geospatial data, device generated data, and unstructured data, this actually goes to the Spark based and Kafka based system. There's a play of Databricks there. They're building Python based models, data science models, but at the end of the day, it basically actually goes through Denodo platform. And sometimes, depending on the use case, you need to consolidate the information that comes from the data lake layer versus the data warehouse layer, and that combination happens to Denodo platform. So you have everything consolidated one single view. So I had to rush a little bit because I had a lot to share, but this is just the key takeaways. There are all these 6 different pillars. We already spoke about it. Those are very important to create a logical data fabric. Unfortunately, our platform has all of it. So instead of making it a composable architecture with our platform, you can actually create your enterprise logical data fabric for your day-to-day data needs. So that's pretty much it. More than happy to take some question and answers here. And at the end of the presentation, there are some information in terms of how to get started with data virtualization. If you think data virtualization is way to go, you want to create a logical data fabric for your enterprise, then check us out at denodo.com/free trials. We have for you, there are these 30-day free trials where you can try us in either one of these like cloud platforms, step-by-step process, very easy to understand, very easy to learn. So with that, happy to take a few questions here.